So hi, you guys are there, right? Shubhda? Let's just test once. So we have our viewers. The broadcast will start exactly at 11:30. But you guys are there, right? Ravi Kiran, I can't hear you. Maybe it will take some time for the voice to come. Okay, we'll start exactly at 11:30 then. Okay, so I think it is there. I think at least my voice is audible. I can see that. Huh? ठीक है. You guys start at you guys start now and then go ahead and initiate exactly at 11:30. But you guys be there right now. Okay. You start now and then go ahead and
maybe I don't.
11:30. But you guys be there. Right.
Sir, can you hear me?
ये क्या है? नहीं लगाया मैंने. तू कैसे लगाओगी? अरे
You start now and then go ahead and
Maybe I don't.
11:30. But you guys be there. Right.
Sir, can you hear me?
ये क्या है? नहीं लगाया मैंने. तू कैसे लगाओगी? अरे
देखो.
Can you guys hear me? Hello. I can't hear any one of you people. I don't know why. Ravi, I can see you, but I cannot hear you. Can you guys hear each other? You guys can hear me, right? But I can't hear you. Can Shubhda and you people hear each other? I see Saujanya, I see Ravi Kiran, I see Shubhda. Can you people hear each other? I can't hear anything at all. Now I can hear someone.
now
Hello.
you're able to hear me.
I can hear you people. What was wrong?
Microphone was off.
Oh my goodness. Okay, so people, Ravi Kiran, I can't hear you. Your mic is off. Can you guys hear me?
No, he says that his microphone is on, but still he is unable to hear you.
No, I can hear you now. Ravi Kiran, I can hear you. Talk aloud. Say ABCD. Ravi, I can see you, but I cannot hear you. Okay, there's a lag. That's all. That's the problem. All right, you guys carry on. Introduce yourselves. Maybe one of you can start. I will join in exactly 5 minutes. Right. I see Saujanya, I see Ravikiran, I see Shubha. Can you people hear each other? Hi Saujanya, the video has started. Carry on.
Hello everybody, welcome to the first live session of Discrete Mathematics course. I hope you're all enjoying the weekly content. Thank you all for your feedback, whatever you're giving. We see that you're really interested and interactive in the course. You ask a lot of questions in the discussion forum. We'll always welcome more questions and we're happy to answer all of them. The course instructor Sudarshan sir will be joining in a few minutes. Till then, I would like to introduce myself. I'm the TA, one of the TAs of Discrete Mathematics course. I'm Saujanya. We have with us Shubhada and Ravikiran, both of them are TAs. Sir will be joining in a few minutes. So this is the first live session. We'll be conducting more of such sessions every month. And then whenever we get a lot of queries from your side, we can arrange for more live sessions. Hello everybody, welcome to the first live session of Discrete Mathematics course. I hope you're all enjoying the weekly content. Thank you all for your feedback, whatever you're giving. We see that you're really interested and interactive in the course. You ask a lot of questions in the discussion forum. We'll always welcome more questions and we're happy to answer all of them. The course instructor Sudarshan sir will be joining in a few minutes. Till then, I would like to introduce myself. I'm the TA, one of the TAs of Discrete Mathematics course. I'm Saujanya. We have with us Shubhada and Ravikiran, both of them are TAs. Sir will be joining in a few minutes. So this is the first live session. We'll be conducting more of such sessions every month. And then whenever we get a lot of queries from your side, we can arrange for more live sessions. So you see that I hope you're all enjoying the content. So the first week's content was the counting chapter. We started with basics of counting. It involved it had a lot of topics like permutations, combinations. We started off with the basic counting principle, rule of sum and rule of products. Then we moved on to some uh, techniques of counting permutations and combinations. We also saw some binomial theorem and multinomial theorem. And then we moved to the last topic, the slightly advanced topic, Catalan numbers. So I saw that there are a lot of questions based on Catalan numbers in the discussion forum. So we can ask sir to speak a little about Catalan numbers and clarify your doubts. Many have asked what are the applications of discrete mathematics. It will surely help you in computer science. I'm sure you must have seen a video in the first week where sir speaks about how counting and in general discrete math is useful in computer science. The trailer even spoke about that. We then had set theory chapter where it was required to build your knowledge further. Like permutations, combinations. We started off with the basic counting principle, rule of sum and rule of products. Then we moved on to some techniques of counting permutations and combinations. We also saw some binomial theorem and multinomial theorem. And then we moved to the last topic, the slightly advanced topic, Catalan numbers. So I saw that there are a lot of questions based on Catalan numbers.
Look at the questions on YouTube. You just talk.
So most of you would have seen we have introduced a new concept, something like called as DM Wiki. It's a wiki initiative from our lab of IT Ropar. What we have done is we have created a portal where it is available for all your students to come and create your notes over there. You must have seen the super notes section in the main page. So I hope most of you would have registered for DM Wiki. If not, please do register. It's been 3 weeks now. We have always been telling in the discussion forum, please log in, please register at DM Wiki whenever we answer your questions. So once you register to DM Wiki, you can, through your Google account, that is through your Gmail ID, when you create an account in DM Wiki, what you can do is you can see a main page which shows FAQs and super note section. And you can also see the playlists of every week there. So once you log in, you just click on the super notes section. You can see weekly content available. What we expect is a lot of you coming and feeding in content there, editing the super notes section for every week. We have seen one of our friend named Shubhadeep has been doing it from a long time. For every week, he is very enthusiastic to add in content over there. I hope most of you will join Shubhadeep and create a very nice super notes section in the DM Wiki part. A few questions have been added on FAQ section where you see some basic questions related to your assignments, videos, and how to upload images when you're typing in content on Wiki, and how to add videos, etc. So the main part of DM Wiki is it works like how Wikipedia works. I hope most of you are aware of Wikipedia. You add in, you edit content, and a nice article comes out at the end. And we wish to see every week's content, the super notes, the lectures, which is transcribed as text in the super notes section.
Am I audible, Saujanya?
Yes, sir.
Okay, so when I start talking, you should mute the microphone so that
Sure.
others get echo.
Sure.
And people, please don't mind. My TAs are new to this Google Hangout session. They get used to it in the first attempt, and second attempts onwards, we'll do it in a much more professional way. You heard the echo coming. You did not hear us talking and stuff like that. So Shubhada, Ravikiran, and Saujanya are the TAs for this course. Shubhada, Ravikiran, and Saujanya, ensure we follow the following protocol. When we are talking, our microphone and video should be on. When we are not talking, both of them should be off. And when we are talking, do not open the live session, but you may have to open the live session to look at the messages. What you do is you mute the live session in one window, look at the messages if you want. A better idea would be to not look at it when you're talking. Okay, so now I have opened the live session. I'm seeing the chat messages on one side, and I'm looking at the camera on the other side. So it will be difficult for me to do both, but I'll try to ensure that I do both. Saujanya, maybe your video can be switched off. Ravikiran, Shubhada, also your videos can be switched off. Let me now start with the introduction. Okay. So the course has been going pretty well so far. I am happy to see the reception. It feels good to see that some of you are interested to know more about the subject. Okay. Before going there's some of the frequently asked questions on behalf of my TAs. They're struggling to see the ends meet, your question and their answers. Some questions are repetitive and we tend to answer it again and again and again. I have a few suggestions for you people. Whenever you have a question, okay, ask it on the forum. Don't ask us individually, because we may take our own sweet time to get back. Sometimes one TA will be assigned for the forum. If you ask others personally, it may take even days for them to get back. If you post on the forums, they will get back immediately. And in case you post on the forum and still you don't get an answer, you send an email to me stating that question asked, no answer yet. In the subject line, you can put and then send it to me, and I'll alert my TAs to get back immediately. There are situations where you ask a question and we don't get back. That's because of the volume of the mails that we keep getting, and sometimes some mails get lost and we wouldn't have seen it. I would have seen and started, we wouldn't get back to it. I mean, 1 in 100 mails happen to skip our mind. Okay, oversight error. So, okay, so that's one problem. Second problem is many of you are requesting for registrations even now. Very sorry, it's not in our hands. NPTEL office also has some restrictions. They have to have a start date and not be too very flexible. They have been very flexible in the sense that they have given the opportunity for you all to enroll for like first 2 weeks, right? After that, it was stopped. Assignment due date was extended, like almost I would call it indefinitely, because 2 weeks is close to being indefinite. The first assignment's due date was 3 days ago, 4 days ago, 14th of August, and second one was immediately next. And beyond this also, many of you asked for extension. Please know that it would be difficult for us. And some people from Kerala, we are very sorry that what is happening to some parts of South India. Hopefully everything will recover soon. Our prayer is with many of these states, especially Kerala. But we are being very considerate on this matter, and NPTEL is having a meeting and they will get back to you people immediately, roughly in a day's time, on if you can submit assignment later as well. This probably will extend only to people from the flood affected regions. Okay, so that's with the assignment. I see many of the questions are about assignments and submissions and things like that. Very few questions on discrete math itself. This is the case in the other subjects also. We are offering 3 courses this time: social networks, discrete math, and joy of computing. In all the courses, we are observing this, but that's understandable, because first few weeks you should get a hang of what is the portal and things like that, right? So one of the most frequently asked questions is the very, very rudimentary one. Where are the videos, right? So when you click on the login link there, you type in your user ID password, and you go to the top left corner. It's a mirror reflection, so my top left corner will sound like right to you. So top left corner of your screen, and you will see the videos, and you will see assignments. If you haven't watched videos, it's too late. But then I have one word of advice. Many people who are taking up this course, they are taking it up for the sake of learning. If you're taking it for the sake of learning, you just have to watch the YouTube videos. If you're taking it for the sake of examination, that's different, right? You have to be very concerned about assignments, quiz, marks, and portal usage and things like that. If it's only for knowledge gain, which I think majority of you are here for, do not worry so much about assignments, is my tip for you all. Because I've been telling people, they say, sir, I have not submitted my assignment. Will this bother the course, the later part of the course? Will I be able to continue with the course and things like that? So please note, if your motive is not to get a certificate, you needn't worry about assignments. And more than 90% of the crowd is here just to learn. Okay, go ahead, learn at your own pace. Ask any question, anytime. We are there to answer. As I said, if we are not answering, put a mail to me. I will request my TAs to take action immediately, meaning to reply back to your answer. Okay, that's with the non-technical part of the discussion. Let us switch to technical part, because discrete math is a very, very beautiful, beautiful, beautiful subject that at least I have encountered in my life. I'm so much in love with the subject that there used to be times when I used to feel bugged and bored, and I would take up some problem from discrete math and then solve it. I even have it. I have seen it as a piece of entertainment for my mind. I'm sure you all will see the same as well. So it is very beautiful. It can be a little tough. Okay, before going any further, we'll discuss a few. I have a few points to write down. I will discuss all of them one by one. But before that, I would want my TAs, Ravi Kiran, or Saujanya or Shubhda, to point me to some of the frequently asked questions, the non-technical part, so that we can quickly finish that and enter the technical part. Yeah, please go on.
Sure, sir. We have actually received several questions on Catalan numbers and their applications. So it would be good if you can talk a few words on Catalan numbers. I'll ask the next question. I'll pose the next question after you speak about Catalan numbers.
Okay, so I thought we'll keep all the non-technical discussions as we agreed upon in the first part, and then switch to the technical discussions. Catalan comes in the technical discussion. So what we'll do is, maybe, do you have any questions about the portal, or about the assignments, quizzes, due dates, or anything that you can think of that is a question nothing to do with the discrete math syllabus?
Some basic questions were like assignments I'm not able to submit. Can I do resubmissions and all? I think we have answered most of them, that you can do multiple submissions for all the assignments, and assignment 0 will not be credited. I think these were the main questions that were asked.
Okay. So that means we can enter into the technical part right now.
Yes, sir. Yes, sir.
Okay. All right, perfect. So Catalan numbers will come. That's the fag end of the first week. So discrete math in general, I had to talk, and then I'll switch to Catalan numbers. That's the first question that Saujanya asked. Maybe Saujanya, you can help me with the questions by picking from the chat window. I have this problem of, if I keep seeing the chat window, my eyes will be somewhere else. You will not sense that I'm actually facing the camera. So I'll just face the camera and talk. Saujanya can probably intervene and give me questions from the chat window. So to begin with, we will start with discrete math as a subject. Okay. We have given the intro in the course. The intro remains the same. In fact, discrete math is a subject which is a bunch of several subjects. Okay, it is, let's say, it buys ideas from some topics in modern math, like how do you count, some topics from slightly old mathematical concepts like functions, relations, and all, which has been there from several hundreds of years. And it also does buy ideas from this popular subject called graph theory, which has seen its applications in various walks of life, including several engineering disciplines, medicine, sociology, economics, and whatnot. So, discrete math for computer scientists. I hope you all are computer scientists. If you are not, just raise your hand in the chat window. I would like to see who is a non-computer scientist who is curious enough to take up the subject. I would like to personally talk to them and then see what brought them to discrete math. I'm just curious. So discrete math for a computer scientist is meant for the following reason, that whenever you encounter a problem in computing, the problem generally is, how do we compute something fast? Is our method efficient? Be it a basic sorting algorithm or an advanced artificial intelligence technique, the question remains the same: is my algorithm efficient? What do you mean by efficient? You say, if a worker comes to your house and says, I will get your washing machine repaired. If an engineer comes and says, I'll get your washing machine repaired, what do I mean by, is he efficient enough? What do you mean by that? Can we define that? Yeah, the definition would go something like this. Can he fix the stuff well without damaging my machine? And can he do a good job quickly? Correct? Can he do a good job and can he do the job quickly? Similarly, a piece of computer program needs to be evaluated on these two fronts. One is it doing what it is supposed to do? Secondly, how much time will it take? Right? So my engineer will take more time if I have several washing machines. If it is one, he takes less time. If it is two, he takes twice the time, maybe, assuming the problem is the same. If there are 10, he gets tired at the end and he might take a lot more time than 10 times. What I'm trying to say here is your computer algorithm might take different time for different sizes of the input. Firstly, is it doing its job correctly? Is your sorting algorithm really sorting? Right? That is called the proof of correctness in computer science. You should check that whatever is being claimed is actually correct. Here is a product. This product does this. Does it really do that? Right? Recently, I bought this Alexa device, right? Amazon's device, and I wanted to see whether it does what it claims to do. So I spent a lot of time trying to see everything that is being claimed that this device does. Similarly, there's a computer algorithm. This does sorting. I should see whether it really sorts or not. How do I check? By giving only one sorting instance, giving, let's say, okay, sort these 10 numbers. Oh, it's sorting, perfect. That's not the proof, right? You should try multiple instances. Even after trying multiple instances, you don't know if the algorithm will fail on some instance, okay? So you need a proof to show that your given algorithm actually works the way it is supposed to work. Now, that is non-trivial. For some algorithms, it's straightforward. Add two numbers. Is it adding or not? You can check the code and say, hey, you're doing A plus B. Done. But there can be very complicated algorithms where we cannot check whether the algorithm is doing its job correctly or not. And that is where discrete math pitches in a very strong way. Discrete math helps you develop the mathematical skills to analyze a given algorithm and declare its correctness. Okay? So why do we use math for it? See, this is like the computer science. To see something is correct or not, why do we need math there? The definition of math, at least as I see it, is doing science in an organized way, in a way where abstractness can be brought in. Why do we bring in abstractness? So that we are precise and unambiguous. A statement like, I like you very much is a very ambiguous statement. You see, me saying, okay, let's meet tomorrow means we'll meet tomorrow at what time, for what sake? You know, there are so many other questions. English is a very ambiguous language. Math is that way ambiguity free. That's why we use math. Math is basically a super spoken language where people cannot make a mistake. So when you say, let us consider this, you consider that. There's no second thought about not considering or considering something else. So we use math to show the proof of correctness of an algorithm. And this math mainly is what is called the discrete math. Okay, majority of discrete math is to develop tools to check whether something is right or not. One. Second one, as I was telling you, is an algorithm runs differently for different inputs. You see, it is more like a function. A function takes a value and outputs some value. Your algorithm is more like it takes an input, and I would want to see, I would want to compute what is the time that the algorithm takes to answer a question. That time is the output of this function. I'll call this function, let's say, the time function. To make this complicated stuff easier, all I'm telling you is you ask me to do a dish, prepare a dish, and you judge based on the time I take to make the dish. Let's say, not the quality, for the time being, let's say you only judge me based on time. You say, Sudarshan, please prepare Maggi for me, noodles for me. Noodles is a 2-minute task. I'll go and quickly boil noodles and then serve you. I do it in, let's say, 5 minutes. You say, very good. And you say, Sudarshan, can you help me with a nice sweet dish, maybe a milk cake? I will take 1.5 hours for it. Right? That there you will know my efficiency. My efficiency cannot be evaluated by the way I prepare noodles, but by the way I prepare milk cake. And maybe you will say, prepare vegetable pulao for me, biryani for me. So that these are all bouncers for me. I'll take ages and I will stumble and stuff like that. So you evaluate me not based on just one question. You evaluate me based on, for different complexities of my demand, how will Sudarshan function? Right? Similarly, you take an algorithm for different types of the input. Right? You ask this question. What time does the algorithm take, right? It all depends on the number of steps in your algorithm. And to count these steps, you cannot just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This takes some 100 steps. You cannot do that. It is actually a function of the input size. And this function is almost always not easy to understand. So it is important for us to understand how much time your algorithm takes for different inputs. That is again a place where discrete math pitches in, and we have discussed this in our video. The chapter on counting is dedicated for this very reason, to count how many steps your algorithm takes. For that, you should know how to count. I start the video like this. Counting is not counting the number of chocolates in the palm of a kid. Counting is a lot more than that. Counting is, let's say, counting the total amount of bacteria in your gut. That's a non-trivial problem. So counting can mean anything. So counting in computer science means count the number of steps that your algorithm takes. Also, sometimes there are instances when your algorithm doesn't stop at all. It keeps running forever. And you may have to understand that your algorithm enters this infinite loop state through math. So discrete math is a surgical procedure to analyze algorithms, and algorithmic complexity is understood by this kind of math called the discrete math. Okay, so these are like me teaching you how to drive over this Google Hangout. So for me to tell you how one drives, I should make you sit in the car, sit next to you, and then teach you how to drive. So it's tough for you to read about driving or watch a Google Hangout session about driving. You will come to driving and then you will realize, perfect, my knowledge of discrete math is helping me big time in understanding the efficiency of algorithms. Okay, in that connection, this subject has a few topics. We have picked the topics that we think are important, let's say, for modern computer science. The subject is as ancient as computer science, even beyond that, but it's a collection of a few topics. Okay, these topics did not start with computer science. They were already there, but they were plucked out from different forms of mathematics and accumulated in one vessel. Okay. All right, so we discussed more about counting in the first week, right? We saw permutations, combinations, and combinations with repetitions, the ice cream example, and several problems. And finally, I actually thought, should we really introduce Catalan numbers to you people? But then I thought, so many students, and most of them will find the the age-old NPR, NC, N choose R and the formulas to be very boring. They want some advanced content. So I included Catalan numbers. So don't worry much if it sounded Greek and Latin to you people. You will get to know of it with time. The idea is very simple. The idea is to count a particular thing, particular system there. And that system appears very frequently in computer science. You Google for Catalan numbers, the Wikipedia entry itself is so exhaustive. It shows you several places where counting is being used. Okay, so Catalan numbers stands for the kind of counting that one should do to measure, let's say, the number of ways you can put brackets and then close them, the valid ones. Okay. It also talks. I might sound a little technical here. I'm sorry. It also tells you how to count a particular kind of tree that comes in computer science very often, called the binary search tree. Don't worry if you haven't heard of it. When I first encountered Catalan numbers, I didn't know its connection with binary search tree. I knew both the concepts. It took me some reading to understand that these two are connected. And once I saw the connection, I felt that gave me a high. Oh wow, they are so beautifully connected. So I saw one question just now. I always saw a question right now in your chat window. Someone asking, how do we apply Catalan numbers on an application? It doesn't come very easy. It takes some time. You should observe that the problem here is that of the problem in Catalan numbers, and you should map it properly. That mapping is not very easy. It is not one size fits all. It is different sizes for different problems. Okay, so I cannot answer this question because there's no answer. Basically, you should with time maybe you'll realize how to map what with what. But as of now, we should take it cool and only look at some problems where Catalan numbers do appear. So the reason why I introduced Catalan numbers is also because the proof is so elegant. You will understand what is a mathematical proof properly when you look at this question. And the best part is that the proof is very cute. You know what you do there? You do the following. I ask you, count the number of people in the classroom. Okay. What you do is you get some chocolates from a vessel and distribute one each to everyone. Okay. And you see that no chocolate is left out and all chocolates are being distributed. And everybody has got one chocolate each. What can you conclude? You can conclude that the number of chocolates that you had in your vessel is equal to the number of people in the classroom. So when we say count the total number of ways in which you can start from the bottom and reach the top without crossing the fence. However, you can touch the fence but not trespass the fence. You cannot go beyond the fence. You see this problem as some other problem. You see, you put a stick and then take the complement on that side. This is something. This is a very weird thing on this side, like chocolate in the vessels. That has nothing to do with the people in the classroom. But then you map the chocolate in the vessel to people in the classroom, and you declare that both are of the same size, same numbers. Similarly, what we do in Catalan numbers is we put a vertical bar after something. You know what that something is if you have watched. It is when there is one R more than you, one R more than you, you put a, that is when you cross the fence, right? You put a vertical bar, and then what you do is you toggle on the right side. So you end up getting more R's than U's. Okay, that's a completely different system. And you observe that there is a one-to-one correspondence between this vessel of chocolates and the number of possible moves, which is the number of people in the classroom. And there's a one-to-one correspondence. You know the number of people this side, the total possible ways in which you can have one R more than you, and then you map it one-to-one this side, and you say the answer to this is equal to answer to this. I know the answer to this, and hence I know the answer. Correct? That's Catalan numbers in a nutshell. So you may want to watch the video once again. If you don't understand it, please tell us where exactly you're not understanding. We will help you out. Okay? So, Sonia, more questions based on the chat window, which I am not seeing right now.
Yes, sir. They are asking about logic, the later part regarding syllogism and open statements. They're asking it has remained undiscussed. So, when will you be doing, or will you be even doing?
Okay, so it so happened that logic chapter already has come to 3 full hours. 1 full week. If we do logic 1, logic 2 right now itself, it will be a whole lot of logic, correct? That's why if you remember, I do end the week by stating that basics of logic we have covered, advanced topics in logic will be covering later. Okay, I state that, which we'll be doing. I have 2 reasons for it. One reason is I want to see how you people have grasped the subject. And then we are ready to record the advanced part, by the way. I mean, discrete math chapters are being recorded parallelly as the week goes by. For example, next week's video we have just released. Okay, and we will plan what will be the 4th week's video. We have a nice plan in our hand, but we slightly fine-tune it and modify it based on the reception by the crowd. But one thing is assured, everything that is part of, let's say, the GATE syllabus is a standard yardstick which says this will be the syllabus across the nation, right? We will ensure that this course goes in such a way that you can answer all the GATE questions from discrete math. That part of syllabus will be covered. You're right, some part of, let's say, first order logic is probably not covered, at least the terminology is not used. Predicate logic is not covered. We'll be doing all these things as an advanced logic chapter. Also, we have just released the relations chapter for the next week. We are not covering the advanced part. We'll be releasing it a few weeks later. Why are we doing this? Probably some of you are hell bent on being organized, might say, sir, finish the entire chapter. Why do you want to give it in 2 pieces? So you may want to patiently understand this point, a very important point. Math of all subjects works very slowly in your subconscious. You understand something, it takes some time for it to mature. Even without thinking about the concept will be maturing in your mind. Okay, there are times when you don't understand a math concept, but after a few weeks, suddenly it comes as a shiny, radiant revelation to you when you are, let's say, riding a bicycle or taking bath or watching television. You quickly get that, this is what the concept is. It takes some time for you to internalize. If we cover the basics and without strong foundations, we go to advanced and expect you to even solve assignment questions on it, that's a spectacular way to inculcate discouragement into you people. So Saujanya has teacher's degree called B.Ed. She's from NCERT school, which is a very popular college in India for education. So the teaching pedagogy part she handles, and it's me and her who discuss that pouring in a whole lot of advanced topics in one go is not a good idea. Let's have part 1 and part 2 for some subjects. So logic, relations, we will do in part 1 and part 2. In fact, the first chapter, counting, also has an advanced component called advanced counting. We will be using some very heavy duty machineries there. We wouldn't want to do counting 1, 2, 3 in for the first 3 weeks. You see, that will be very detrimental to your progress, to your inspiration levels and whatnot. So we are sticking to this idea of covering the bare minimum basics of a subject, moving ahead, and then revisiting these topics in the fag end of our semester of the 12 weeks course. Okay, so don't worry, rest assured, everything that GATE syllabus assumes that you know will be covered in this course, right? Okay, we can go to the next question, sir.
Sir, next question is, they've asked something about Pascal's triangle. They want more insights. I think they were really happy with the Pascal's triangle video.
Okay, so Pascal's triangle video was nice, and trust me, okay, it's something that I must tell you people. This was done by our friends, our TAs. Mainly Ravi Kiran did the animation part and also content part, and Saujanya also gave a lot of ideas there. So Shubhita was also part of it. See, once I watched the video, trust me, I should not be declaring this on a public forum. More than 50% of it, I did not know. I have been teaching this subject for like ages, close to 14 years, let's say. 2004 was the first time I handled this course. Until date, I'm teaching, of course, with some gaps in between, but I have been teaching. And I have never encountered some of these fascinating facts. They were all collected by my TAs. And I'm sure you people are even smarter in the sense that you can collect more information about Pascal's triangle. How do we go about it? We have a nice wiki page called DM Wiki. Okay, so it is available on skilabs/dmwiki. Let me just open it. Okay, so in that, when you click, you need to log in, and once you log in, you will get there's an interface which talks about super notes and videos and things like that. There in the super notes section, maybe you can type, you can start editing and then create more articles. So in this connection, I must say a student by name Sudipta, who is from NIT Durgapur, is doing a wonderful job in populating the wiki with his own articles. I think we need more such enthusiastic souls who can come and type stuff. So to answer this Pascal's triangle question, I think we need to have a place where we put all the information that we know on Pascal's triangle. Okay, that should be like a huge repository for reference on Pascal's triangle. Okay, so that should come from your side. I have given my best. I just taught my TAs some basics of Pascal's triangle, and they went ahead and collected a whole lot of stuff on Pascal's triangle. And for you to make it a big ocean, that should be your initiative and motive. We will not be able to pitch in much beyond this point, right? Okay, so someone was asking about resolution principle there. Okay, so see, some of the concepts in logic, resolution principle can be slightly advanced, but some of the concepts in logic are being renamed because logic was a domain used by philosophers. Some physicists also have used logic, and mainly it became popular after George Boole's Boolean algebra and its implication in computer science. Okay, it saw its application in computing, and a brand new language of talking got created. Okay, so if you say X for a concept in philosophy, you will call it Y in computer science, but X and Y are equivalent. Okay, first order logic is one such topic. Some books call it first order logic, some books call it something else, right? So you may encounter logic syllabus as something and you may think it is not covered, but please note, an equivalent term will be used and it will be covered. This is the case with discrete mathematics. A lot of things are being covered under a different name, that's all. We'll be covering everything that is important for your GATE syllabus. Our concentration is not GATE, but GATE is a good standard because discrete math is an ocean. If we go on, it requires 100 hours of talking. I at least have 100 hours of content to teach. I cannot go on teaching everything. Something as nice as graph theory, which is part of discrete math, is some 2 semesters subject. Okay, one can even specialize in this subject. So it's a big field. We are not covering everything. We are only going up to a level that is deemed right and enough for a BTech student in the interest of GATE syllabus, also apart from his expected knowledge that he's supposed to have in his BTech or BE course. Yeah, next question.
Yes, sir. One person has asked about the application of combinations with repetition.
Okay, so see, some of these questions, I understand it will be difficult for you to relate to what I said about algorithms, complexity, counting, correctness, with something as simple as combinations with repetitions, Catalan numbers. Sometimes a concept that is required to test an algorithm might require a prerequisite concept, and that concept might require another prerequisite concept. Okay, this is like you want to meet the local deputy commissioner of your town, and you cannot go and meet him directly. You probably should meet his personal secretary first, and then to meet his personal secretary, you should know someone who knows him. And for you to know him, you should know someone, some relative who knows this, someone who knows personal secretary. So you should not ask about why should I talk to the personal secretary while my motive is to meet the deputy commissioner. I'm just giving you an analogy so that you get what I mean here. So combinations with repetitions is a prerequisite for counting in systems where you choose something and you count the total number of ways in which you can choose. That might be an application of something, that might be an application of something else. Actually, I have an application for you right now that will be quite advanced if I talk. Okay, so you will realize that there are places when we are talking something and we quickly invoke the combination with repetition concept. We'll quickly invoke binomial theorem. Binomial theorem directly may not be applicable, but it is one of the builder blocks in the big wall that we are going to construct. Okay, you will realize it. You will realize that whatever we have discussed right now, we'll be using them in graph theory, right? And graph theory is directly related to computing in directly many ways, although there are indirect ways of application. Directly many ways we use graph theory there, and for graph theory we need a lot of content. Okay, so this is the answer for this question. It's sort of difficult for anybody, for that matter, to tell you what is the use of gravity in understanding the escalator technology. Of course, escalator technology uses gravity. What is the use of gravity in rocket sciences? It uses, though not directly. Gravity implies something, implies the rocket science. Okay, so my call for you all is this subject involves some abstraction. It can be a little discouraging that you don't see a point but you're asked to study. Please study this subject in its own right to begin with. A kid who wants to read an advanced book should start with ABCD. When he reads ABCD, he may not see a direct implication. But slowly from ABCD, he will frame words, he'll frame sentences, he'll frame paragraphs, he'll understand grammar, and then, boom, he can start reading Shakespeare, right? So it's a gradual process. Okay, let me read out some questions here. Please provide classes on generating functions as well as recurrence relations, as GATE 2019 is coming. Arijit Datta, GATE 2019 is a parameter that for some of you people, but for us, we are going to keep a bunch of videos which will be there like forever. Okay, we are working towards coming out with a syllabus which is important for everyone and for years to come. To answer your question, very good amount of generating functions, very deep amount of generating functions. You take all possible things in generating functions, that is part of BTech syllabus. We will be covering all of them. That we are going to spend one full week's time on generating functions. Recurrence relations is one topic where you will not see this is then this is, and then finally it's applied. Recurrence relation is directly applicable in computer science. If you see what is called a merge sort, sorting technique, it uses recurrence relations. Simple. If you see what is called a binary search, okay, in computer science, you can analyze binary search by recurrence relation. That's one topic that is directly applicable, and we are going to do maybe even more than 1 week discussing only recurrence relations. So we'll be doing that not just with the upcoming GATE exams with our mind. That is just one of the many aims we have. We want to teach this subject to you people. Okay, and we want to teach it the way it should be taught to a computer science student. That's our motive. Okay, Subhash Singaroy says, any relation between discrete maths and applications of dynamic programming? Very much yes. Dynamic programming gives you a quick recurrence relation, and you may have to solve it, and knowledge comes from discrete math. See, although I introduced the subject by telling you that it is important for computer science, sciences subjects in general should be studied for the concept's sake. Should understand concept 1, move to concept 2, move to concept 3. At the end, some concept will be applicable. You should not worry so much about, is this useful here? Is that useful here? Discrete math, the syllabus that we are going to teach you should be studied, trusting us, thinking that the syllabus will meet the expectations and demands of a BTech student in terms of his knowledge and in terms of some competitive examinations. Okay, perfect. So any other question? Unfortunately, no. Prasun Tiwari says Ravikiran Rao. So Prasun Tiwari is the one who asked about resolution principle. Prasun, if you want, resolution has volunteered to help me. If we can volunteers like that to schedule a session like this where exclusively we talk on one topic. I'll keep my writing pad here and I will write and show you a few advanced stuff. We'll be organized. I am also a human being. I don't know everything in one shot. If you ask me to teach, I will not be able to teach. Let us pin down on a couple of concepts and discuss only that, and I'll tell you everything of what I know about it over a specialized live session like this. Okay, this first we will soon go to the live mode, the proper live mode, where we will have, let's say, these sessions once every 2 weeks or once a week, where we will have a particular theme which we'll address. For example, this time there is no theme. I'm just addressing where the FAQ onwards will ensure that we'll resolution principle if many of you want to understand resolution principle. If many of you want to understand some 10 applications, so I see the he is answering your questions over there. Naveen says video is breaking for me. That's probably because of the internet connection. This will be recorded live and kept online. You can watch it later too, no problem. Okay, so Arijit Datta says, honestly, the way you and your TAs explain everything, I'm grateful for MHRD and NPTEL. Yes, even we are very grateful to MHRD, especially NPTEL, where NPTEL has been very, very understanding in letting us experiment with the syllabus, audience, and even them for that matter. So this is a kind of course where we're trying to bring in some sort of unconventional teaching so that it reaches you people instead of a typical blackboard teaching where we go on with proofs and theorems and things like that. Even that is interesting, important, but for a crowd like this which wants, being computer scientists, you want to learn the math for computer science. The math for computer science should not be taught like the math that is taught in MSc math course, or let's say MPhil or B math, whatever. So the pure sciences part of it, we're sort of cutting short and we're giving a different flavored stuff for you people. So NPTEL and MHRD has allowed us to do it. So thanks to them. And also, Arijit, there are many people like you who keep giving us good feedback that drives us. More the feedback that you people give, better will be the content in the forthcoming weeks. In fact, I am stopping let me tell you people something. I am stopping my TAs from doing the following. They want to get into this adventure of solving all the gate questions from the past few years on discrete math. Okay, that will be very heavy for them, but trust me, if time permits, they'll definitely do it. Whether or not I'm going to allow them, they're very keen on getting it done. So it all depends on how much of interest that you people show and the kind of feedback that you people give. It all depends on that. In this connection, I must suggest I'm very, very inspired by one student by name Shubhadeep, who is very active both on the forum as well as on the wiki. So I need more such people. Please come forward, write to us, tell us how you can help us better the course, tell us what you will be doing for the course, and we will clap hands together. Okay. So Priya Leon says, principle of inclusion and exclusion. We will discuss everything that we know about principle of inclusion and exclusion. That's another chapter for one full week, Priya. So you cannot ask for more after that because you'll be tired of principle of inclusion and exclusion. We will go to chessboards and try to analyze some nice, cute, very cute chess problems called the Rook polynomial. You can associate polynomials with chessboard, and that's a very poetic association. Okay, just the way generating functions are. In fact, someone asked for generating functions. I forget the name. Who was that? Generating functions. I don't remember. Okay, so generating functions again is a topic where beautifully infinite polynomials are attached to sequences, and some very straightforward questions appear very difficult, but if you use generating functions, it becomes very easy. Right? So we'll be discussing that again for 1 week. Whatever you guys are asking, that syllabus is for 1 full week, and it's coming ahead. Algebraic structure. Okay, this is where I have a small issue. Our team is pretty strong with this topic called algebra. We have studied the entire subject and even advanced stuff in algebra. But our question is, up to what level should we go? We will try to see that and then include that in the syllabus. We have kept that pending. Maybe we need input from you people on what part of this algebraic structures do you want? Just groups or its application in cryptography? So Rashmi Selvi asked this question. So Rashmi, it will help if you can tell us why would you need algebra and where would you need algebra? In terms of cryptography, yes, we can tell you bare minimum algebra, but then it's a huge ocean. We can be going on and on. For GATE syllabus, you need to know very, very less, right? But as a subject called algebra, you need to know a whole lot. So depending upon what you want, we will try to craft something and then teach it in maybe the second last week. Sanjeev Kumar says, sir, can you clear the example to reach 5, 5 from 0, 0 without crossing diagonal using different way? I'm not so sure what example that we have used that you are referring to. Maybe you can try writing and then sending it to us. We will try explaining it. Logic puzzles are quite confusing. Is there a generic way to solve such questions? Prasun Tiwari, there are no generic way to solve any aspect of math. I want you people to know this. I have been a teacher. I have taken up these competitive examinations. I know what happens here. If someone tries to tell you that there is one trick that can be used to solve all problems, then that person is fooling you. Let me say this very bluntly. There is nothing called one size for all sort of problems. If there is some such one formula, one mantra, one magic wand for all problems, then we will ensure, people who set gate questions will ensure that we'll go slightly outside that mantra. So if you know a trick to solve a class of problems, I'm addressing this logic puzzles. Prasun Tiwari's nice question saying, is there a generic way? If there is a generic way, please be very careful to know beyond the generic way, because that will be the question that will be asked in your competitive examinations. Forget competitive examinations. In general, math is all about the elegance of some questions that use the existing concepts but requires something little more than that. Okay, so don't fall for these generic methods. They don't exist to the best of my knowledge throughout this subject, at least. Okay. Any other question? Career advice, sir. I'm an MCA pass out, still I have not just prepared GATE, etc. I want to start GATE for Discrete. What are your suggestions? So we get a lot of this question about I am this, that, I want to clear GATE. Yeah, of course you can go ahead. GATE isn't a very difficult examination. In fact, many people get bogged down by the sheer amount of syllabus, but otherwise, if you are consistent, if you just prepare questions based learning, so you should not finish subject and then answer questions. You should look at the questions and then prepare accordingly and then come back to the questions. So that's the best way to prepare for GATE. Go ahead, good. So if you're an MCA, you will benefit from clearing GATE. But I would say I would like to see more students from this course who would love discrete maths for the sake of it. Now, because this is like you go watch a movie. There's also this aspect of entertainment in the course that I want you all to see. You go watch a movie, you don't ask much about its applications, right? You don't worry much about, I watched this movie, what next? Nobody asks that. So discrete math, I've now studied, what next? Okay, you can ask this question. This should not be the only aim. The aim should also be enjoying every bit of it, right? You saw counting was very beautiful. Logic is very beautiful. The rules of inferences is just a mind-blowing way that you can, how some Sherlock Holmes solves his mystery has some mathematical analysis behind it. You can put it into a mathematical form and see how Sherlock Holmes argues, right? So enjoy the subject as well. The rest, of course, is there, GATE and your marks and your assignments and quizzes and final examination. All these things are important, but more important is enjoying the subject. See it as a piece of poetry. See it as a piece of fiction, okay? Yeah. Any basics to learn? So, okay, see, most of this AI, ML, social networks, Bharat Kumar asks, what should I do after this course? See, this course is basic foundation for computer science. If you don't know this course, people will not take you seriously when you say you're a computer science engineer. At least I won't take you very seriously. So these are the foundations, the ABCDs of computer science. You have to learn it. It will come in one place or the other, but you can of course do without the subject too, but then you will not be able to move a little forward. So it's like you can go and play football, right? Directly. Some skills of handling the ball and putting it towards the goal post. But to be a proficient football player, you need some sort of all-over endowment. You should be very fit. You should probably have terrific calf muscles, thigh muscles, and should be very well built, right? You should exercise well. You should have good hard lung capacity, right? For that, you should probably practice outside the football court as well. Correct. Similarly, if you just want to do some basics of, let's say, machine learning, you can just take the algorithm, its implementation available already, and then use it. But if you want to know the internals, dissect it, try to improvise it, I cannot exaggerate. Subjects like discrete mathematics, probability, linear algebra, good amount of statistics is what makes the current subjects like AI, ML, social networks, or whatever. At the first level, you can always write a code, but at the next level, you need these surgical procedures, sharp instruments called.
Excuse me, sir. I want to disturb you for 1 minute. We have the last 1 minute left.
Oh, good. You told me. So there is no end time, I guess, Saujanya. So we can go slightly more, maybe another 2 minutes, and we can conclude. Okay. So I was telling you that this subject is more like that. It's a sharp instrument, and you need to have it if you want to dig deeper. If you want some shallow understanding of the subjects in computer science, discrete math is actually not required. Trust me. If you want to go to the next level, it is indispensable. Okay, so this is a FAQ that many people ask, so I had to address this. Okay, so next question, maybe we'll take one last question. Are you all there? I don't see the chat moving up. Oh yes, people are there. Assignments you missed, final marks, etc. Maybe Harsh, you can ask this question on the forum and my TAs will answer. Okay. Nihal, how discrete math is connected with AI? How are alphabets connected with English language? Do you think you need to know alphabets to understand what I'm talking? Is the kind of question you're asking. How discrete math is connected with AI? Discrete math is terribly connected with AI. I mean, the connection is so strong that discrete math is not just a prerequisite, but is a building block. I'll tell you something. Discrete math has a topic called graph theory. Okay, and this graph theory is the idea of how things are connected, and AI makes use of this subject like in and out. If you talk about a neural network, that is actually abstract, a small abstract variant of graph G of B, I. All right. So having good knowledge of this will help you do well in AI. There's something called graphical models. Okay, in computer science, which comes in the intersection of AI, machine learning, and you name it, and you will see graphical models there. The graphical models is based on good amount of abstractions that we develop in discrete math. Okay, so it is of course applicable. Do not worry. This is the last question that we will address on. Is this applicable somewhere? You should trust me and go ahead and then study it. It's like a kid keeps asking me, A, B, C, D, why should I learn? I want to start watching Hollywood movies. You will not understand the movies unless you learn English as a language. So wait and finish your kindergarten studies, and then you can move ahead and do your PhD. Right? Okay. So gate preparation questions I will not take anymore. Any other nice questions that you people have? Is Subhadeep there? Sudipta, Sudipta, right? Okay, is Sudipta there? Okay, I think he's not there. Anyways, TS, anything that you would like to add? Maybe if you can tell something and we conclude, we can say bye to everyone.
I think we need more feedbacks pouring in. That is the last, because we can improvise each week based on the expectations and demands what they have. I think we need more of feedbacks, and we need more of editing in DM Wiki.
Oh, that's right. Goes without saying. Yes, people, please come and contribute on DM Wiki. We are going to post gate questions there too, and even solve them eventually. So only people who are active there will benefit from the gate part of our course. DM Wiki is a must for you people. So if you want to get any serious with the course, subscribe to our DM Wiki. By DM Wiki, we mean maybe Saujanya, you can type the link on the chat window.
Sure, sir. Sure.
So anything else, Shubhada, Ravi Kiran, Saujanya?
You asked for Shubhadeep. He has sent a message in the chat section that he is there. Maybe he is not able to connect audio.
Okay, no problem. Subhadeep Patra, maybe a person like you should form a small group with like-minded people from our course, and we should have a separate discussion on how we can better. Please, all of you, please understand this. Someone like Subhadeep has helped us take the course to the next level. The reason why we are able to do well and the forthcoming weeks are going to be even better is because he constantly gives us feedback, and he also inspires us to do more. I want more such people. I'm sure there are many such people out there. You should come forward and talk to us. Okay, feel free to I have given my phone number. You can WhatsApp me and tell me, but do not WhatsApp me about assignment questions, quiz questions, or whatever. I mean, don't talk to me. Talk to me with selfless motive of serving the course or giving us feedback. So I'm always available. This is my number. You can connect with me on WhatsApp. You can, as always, email me. This is my email address. And the course wiki is here, skilabs.org, DM wiki. Just go there, register, and you'll be able to access content. The content is starting to develop right now. You will see the content develop towards even answering gate questions. So be there. Do a good job. As always, subjects are very beautiful. See the beauty part of it. Exam part of it, applications part of it, what next part of it is always there. But please enjoy your present. Discrete math is a mind-blowing subject. Blow your minds off by understanding the concepts. Worry less about other things. Thank you all very much. We'll have another session, maybe specialized sessions from now onwards. So I would say Subhadeep should take up the initiative of conducting the next session. I will be there to talk. He will just manage the logistics. He has agreed for it as well. So thank you all and welcome to the next week. We are going to go take flight very slowly, and we are going to read some advanced concepts. The word advanced doesn't mean complicated. It's going to go over your head. It just means it's a lot of nice stuff. Okay. Thank you all very much. See you in the next chat session. Bye. Maybe the TAs can also say bye quickly.
Bye, everyone.